Well, here we are, new semester, new video. Now we're going to do a standard basic stoichiometry problem today. It's similar to what we've been looking at in class, and we've been looking at the fermentation reaction, so I'm going to use that as my example reaction for our classic stoichiometry. So remember, the basic fermentation reaction, we've been taking sugar, C12, H22, O11, and this is the crude version of the reaction, but that's okay. We'll make use of it for the moment. And water to make C2H6O, that's ethanol. That's the one we're after. And carbon dioxide, that's going to come out in the gas phase. That's coming out in the liquid phase. The sugar was aqueous, dissolved, and that's the solvent as well. And to balance the thing out, this is the reaction we had. So there's our crude approximation for the fermentation reaction. Sugar becoming ethanol and carbon dioxide. Now you saw in class when I measured out the sugar, I had 56.2 grams of the stuff. And the classic stoichiometry problem based upon this is, okay, if you've got 56.2 grams of sugar, how many grams of ethanol are you going to make? That is the classic setup of a stoichiometry problem. You have a reaction, you know an amount of either a reactant or product, here a reactant, and you're asked about how much of something else in that reaction. Here, the product, what we're most interested in, the ethanol. How much are you going to get? Classic stoichiometry problem. And so, quick review for just a second. Remember the basic steps of the stoichiometry problem. Step 1. Moles. Convert whatever you're given into moles. If you're given grams, you're going to use molecular weight and get your hands on moles. If you're given other quantities, like a number of milliliters or liters of a solution, you might need to use molarity to turn that into moles. Heck, if you're given a gas, you might even use the ideal gas law to get moles. Your first step, always turn whatever you're given into moles. Here, I'm given a mass, so I'm going to use molecular weight. The second step is always moles to moles. Okay? Turn moles of what you've got into moles of what you want. And third, moles into ... If you're asked for grams, turn moles into grams. If you're asked for something else, turn moles into whatever. Okay? And so the basic steps here, turn whatever you're given, I should have probably wrote it, into moles. Moles to moles, moles into whatever. Okay? So here we go. For this particular problem here, 56.2 grams. Now, you see it in class, you see it here. Whenever I do these, I'm not just going to write down 56.2 grams. A lot of students will just simply write that down. That's nice, but it's grams of something. And especially when you have lots of different parts of a problem all flying around on a piece of paper, the easiest thing in the world to do is to get it all confused, to have grams and moles and moles and grams of what? You just look at it and you see all these numbers. I strongly urge always to be very careful and write down grams of something. Yes, it takes a few extra seconds to write down the formula of this each time. But boy, it can save your bacon when it's all said and done. So there we go, 56.2 grams of sugar. First, turn that into moles. All right, we know how to turn grams into moles. Grams, C12, H22, O11. Moles, C12, H22, O11. The molecular weight of that thing, I had it over there, 342 grams for each and every 1 mole. Oh, doesn't it feel good to have a classic conversion factor problem? Turn whatever you're given into moles. Step 1. Step 2. Turn moles of what you got into moles of what you want. In other words, moles of sugar. I love it, but I need it to go away. Die, pig, dog, die. Gosh, that's been a long time since we said that. Moles, C2H6O. Moles of what you want in the mole, or moles of what you got in the moles of what you want. Moles are the coefficients of the balanced, has to be balanced, chemical equation. For every 1 mole of sugar, I produce 4 moles of ethanol. There's that. Next, I'm going to get this out of the way. Need a little bit more room now. Get out of there. Okay. And moles of ethanol, that's nice, but that's not what I want. C2H6O. I want grams, C2H6O. We calculate the molecular weight of this thing for a moment. That's pretty easy. It is, and there it is, 46 grams per mole. And there it is. The unit left standing here is going to be grams, and I'll write it down here, C2H6O. How many grams of ethanol can you get from 56.2 grams of sugar? There is the perfect setup for it. And so now I get out the calculator, do the handy dandy calculator dance, and I'm going to come up with 30.2 grams of ethanol. Okay? And that is the amount I should get. Now remember, that's the amount I'll get if the reaction is perfect, if there are no side reactions, if my lab technique is flawless. This is the theoretical yield. Okay, which theoretical yield is essentially the answer to a stoichiometry problem, how much you're going to get. Now, there are plenty of variations of stoichiometry problems, and I'll do a couple of future videos on a few of the variations, but I'll throw one of them out here now, mainly because since the product here, ethanol, is quite familiar to everybody, and it is commonly seen as a liquid, a common question might be, well, how many milliliters of ethanol are you going to get out of this? You know, you have 56.2 grams of sugar. How many milliliters of ethanol can I expect to make from this reaction? Now, that's a slightly different question. How many milliliters of ethanol? Okay. But it's going to be answered pretty readily. Look, we have grams of ethanol. And you remember way back in chapter, which one was it? 1 or 2 or one of those in there. Grams, milliliters. Yes, it's a density question. So all of that stuff from previous work can get kind of thrown in here as a slight bit of a curveball. But that's okay. We can easily handle that. Okay. Once I have my fingers on the 30.2 grams of C2H6O, all I need is the density. To be honest with you, I just sat up in the office and Googled density of ethanol, and it came back with gram C2H6O. Ooh, that should be a 6 right there. And milliliters C2H6O. And when I looked that up, 0.789. 0.789 grams per each and every 1 milliliter. That's what I looked up when I found it on Google, and I punched that out and I get 38.3 milliliters ethanol, C2H6O. Okay, so there's the standard stoichiometry problem, given into moles, moles into moles, moles into what you were asked to calculate, here grams, and then a slight variation that is common in this type of question. How many milliliters? That's a density question, grams, milliliters. Well, we've done that sort of thing. There it is, classic stoichiometry problem in a chapter 3 context here. So, you know, have plenty of chances to practice both in mastering chemistry and in the end of chapter questions. So look this one over, practice a few from class as well, and please let me know if it gives you any trouble. Otherwise, practice a few of these on your own and move on to the next ones. See you later.